In this video, we are going to solve this 9th degree equation. M to the 9th plus m to the 6th equals 36. Now, let's solve this problem together. First, let's express this exponent 9 as 3 times 3 and this exponent 6 as 2 times 3 this way. Then let's recall some properties of exponents. We have here the power of powers, and the right side of this equation is the form of m raised to exponent 3 times 3, which means that we can write this as m to the third all raised to the third. So it looks like this left side of this property. Now, you have here a base of m cubed and another base of m cubed. Let's do some variable substitution. So we let x be equal to m cubed. This can be written in a simpler form as x cubed plus x squared equals 36. Now, let's solve this cubic equation. Let's subtract 36 from both sides so that we can have 0 at the right side. And let's rewrite this so that we can apply factoring by grouping, which means that we are going to express this x squared as the sum of two terms so that we can apply factoring by grouping. In here, notice now that this x squared is now this negative 3x squared plus 4x squared, which when added still resulted to x squared, but this will enable us to perform factoring by grouping if we group these first two terms together and we group these last two terms together, because in here we can have difference of two squares. So this is now what we'll have. In the first group, notice that there is a common factor of x squared. In the second group, 4 is the common factor between 4 and 36. So let's factor out those common factors. Then look at this part here. This is difference of two squares, which is equal to x plus 3 times x minus 3. So let's simplify that. This is the plus sign, this is one term, and this is another term. There's a common factor of x minus 3 and x minus 3 in these two terms. So let's factor out that common factor x minus 3. In here, this x squared times the quantity x minus 3 divided by x minus 3 will be able to cancel out this common factor. So what's left is x squared. Then for this part here, again, this x minus 3 and x minus 3 are common again. So what's left is 4 times the quantity x plus 3, which is now this one. We now have here two factors whose product is 0. So we can now apply the zero product property and equate each of these factors to 0. So x minus 3 equals 0, and x squared plus 4 times the quantity x plus 3 is also equal to 0. Here, we can add 3 to both sides of the equation to get x equals 3. And at the right side, let's distribute this 4 to x and to 3. And we now have x squared plus 4x plus 12 equals 0. So we now have here one value for x. But what is the solution of this equation? Now, the roots of this equation are complex numbers because its discriminant, b squared minus 4ac, is equal to 4 squared, which is 16, minus 4 times a equals 1 and c equals 12. The result here is a negative number, and therefore there is no real root for this case. So getting now the union of the roots of these two cases, we only have one value for x, and that is x equals 3. But remember that we let x to be equal to m cubed. So by substitution, we now have 3 equals m cubed. And solving now for m, we take the cube root of both sides. So m is equal to the cube root of 3. And we now have the value for m. To check if this is correct, let's now substitute the value of m to the original equation. So replace all instances of m by the cube root of 3. Then we can simplify this by expressing this in fractional exponents. So the base 3 raised to exponent 9 over 3. Here, base is 3, exponent is 6, divided by 3 equals 36. Then divide 9 divided by 3 is 3, so we have 3 cubed. Here, 6 divided by 3 equals 2, so we have 3 squared. And 3 cubed equals 27, and 3 squared equals 9. And 27 plus 9 is indeed equals 36. So, the roots of this 9th degree equation, m to the 9th plus m to the 6th equals 36, is m equals the cube root of 3. All the other roots are complex roots. So thank you very much, and we hope to see you again in our next video. Bye for now.